Let us look at proposition number 48 of book 10 of Euclid's Elements. The proposition says to find the first binomial straight line. What is this first binomial straight line? The definition says given a straight line and a binomial divided into its terms such that the square on the greater is greater than the square on the lesser by the square on a straight line commensurable in length with the greater, then if the greater term is commensurable in length with the rational straight line set out, let the whole be called a first binomial straight line. What a mouthful of a definition. Okay, so let's see how we can arrive at this. So which means I have to remove all this. Okay, now set out two numbers AC and BC such that AB is to BC is equal to number square is to number square. AB is to AC is not equal to number square is to number square. So we have AB is to BC equal to number square is to number square. Whereas AB is to AC does not have a number square is to number square ratio. Set out a rational straight line D. Let EF be commensurable in length with D. So we have to draw a line which is commensurable in length with D. Pretty straightforward. We can take any multiple of D. Now, here D is a rational straight line. That means EF is also rational since it is a multiple of D. Now let AB is to AC is equal to EF square is to FG square. So here we don't have FG. So we have to find FG such that this proportionality holds. Okay, we know how to do that. So here AB is to AC is equal to EF square is to FG square. Since AB is to AC is equal to number is to number, from numbers only we have constructed it. So that means because of this proportionality, EF square is to FG square is also having a ratio of number is to number. Now, since it has a ratio of number is to number, that means EF square is commensurable with FG square. And since EF is a rational, that means FG is also rational. EF square is to FG square does not have a number square is to number square because AB is to AC does not have a number square is to number square ratio, which means EF is incommensurable in length with FG. So that means EF and FG are rational straight lines commensurable in square only. That means EG is binomial. Okay, so we have shown that it is binomial. Now we have to show that it is the first binomial straight line. So we have AB is to AC equal to EF square is to FG square and AB is greater than AC. So that means EF square is greater than FG square. Now let FG square plus H square is equal to EF square. Now we don't have this H square. So we have to construct it. Here FG square plus H square is equal to EF square. In conversion, if we do the conversion on this proportion, we get AB is to BC is equal to EF square is to H square. And since AB is to BC is equal to number square is to number square, that means EF square is to H square is also having a ratio of number square is to number square. Means EF is commensurable in length with h. Based on this, we can say EF square is greater than FG square by H square. And just now we have shown that H is commensurable with EF. So EF and FG are rational and EF is commensurable in length with D. That EF is commensurable in length with D is how we started. Let EF be commensurable in length with. So we can say EG is a first binomial straight line. Now let's revisit this definition and see whether it makes sense. Given a rational straight line D and a binomial divided into its terms such that the square on the greater is greater than the square on the lesser by the square on a straight line commensurable with the greater, then if the greater term is commensurable in length with the rational straight line set out, let the whole be called a first binomial straight line. So because of this definition and this construction, we can say that EG is a first binomial straight line. That was proposition number 48 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.